Hello everyone, welcome to Math Freaks. So today, before starting the session, let me talk about a very special thing. So as all of you know that we run a series named Tales of Math, and for the episode 3 of Tales of Math, we have Dr. Amitabha Tripathi sir with us. So he's basically a PhD in mathematics and a professor of mathematics at IIT Delhi, and he was also the regional coordinator of RMO, that is Regional Mathematics Olympiad, that is the next level of PRMO for which we are studying right now. So it's a really great opportunity for you guys to ask your questions to him. So how you can do so? You can fill up the form and ask your questions. The link to the form is given in the description below, so you can go and check it out. So let's begin the session. Today we are going to talk about polynomials, right? As we have finished our discussion of about basic maths, and I hope that all of you have understood what the basic maths. So polynomial is a very simple topic. Like the definition, I'm not going to give much time on the definition because all of you have been studying this for a long time. So polynomial is basically denoted in this form, and the general form of a polynomial is this. Correct? I hope that all of you have seen this form. So now let me talk about this form. Here you see that an minus 1, a1, like up to a1, all of these are known as coefficients. These are known as coefficients of x. In the basic maths, we discussed about the relation between the roots and the coefficients, right, in the quadratic. So I hope that you understand what are coefficients now. And a very special thing, that this an is known as the leading coefficient. Leading coefficient. Now why, we will discuss in a while. Now just remember that an is known as the leading coefficient, and a naught that you see right here is known as the constant of the polynomial. This is a constant of p of x. Correct? Now let us define the conditions through which we can say that this expression is a polynomial and this expression is not a polynomial. So what are the conditions to identify a polynomial? So first one being an is not equals to 0. The leading coefficient, that is this one, cannot be equals to 0. We'll talk about that in a while again. And the second is the most important, that is n should be whole numbers or non-negative integers. I hope that you know why non-negative, because we have to also include 0, and 0 is not a positive number nor a negative number, it is non-negative number. Okay, so that's why we have not written here positive integer, rather we have written non-negative, which basically means that we have to include 0 as well. Okay, so this is the condition. Correct? Now the second condition, like for example, let's see how much you've understood. Can you tell me, these are very basic that I'm talking right now. Say for example, can you tell me if x square plus 5x plus 2 upon x, this is an expression. Now can you tell me if this is a polynomial or not? This is not a polynomial. Why? Because you see this term right here. So if you convert it, this will be 2 multiplied by x raised to the power minus 1. So n here, n is a negative integer, and as per our condition, n has to be a non-negative integer. So this is not a polynomial. Similarly, another example, if you take, say 2x square plus root of x plus 3 upon x. Is this a polynomial? This is definitely not a polynomial. Why? See, this power root of x can be written as x raised to the power half. I sure all of you know this. Since this is half, and see, n has to be an integer, so this, by looking at this term only, we can say that this is not a polynomial. But if we look a bit further, we see that this term is also here. This again turns into 3 multiplied by x raised to the power minus 1. Again, minus 1 is cannot be a non-negative integer, so this is also not a polynomial. So I hope that you understand this whole condition for being called a polynomial and what is polynomial, and I hope that you also understood the general form. Now if we talk about degree of a polynomial, now what is the degree of a polynomial? Say again p of x is equals to a n x raised to the power n plus a n minus 1 x raised to the power n minus 1 up to a naught, correct? Now how to define a degree of a polynomial? There is a very huge mistake that almost all the teachers, like most of the teachers make, is they say the highest power of x or a variable, highest power of the variable in this polynomial is known as the degree of this polynomial. But no, this is partially correct. Now let me tell you why. So highest power of x in this, highest power of x in p of x is definitely the uh, degree of this polynomial, but not always. Now you have to add another condition, that since here n is the highest power in this polynomial, so you can say n is the degree of the polynomial, but you have to also mention that a n cannot be 0. This condition is very important, and this condition will give one conclusion that we are going to make a bit further, that you will understand in the types of polynomial. Okay, so these two conditions are very necessary to define the degree of a polynomial. Not only the degree of a polynomial is the highest power of x in that polynomial, but also you have to define that the coefficient of that variable cannot be equals to 0, correct? So I hope that you understand. For example, say 2x square plus 3x plus 5. Can you tell me, okay, first of all, is this a polynomial? Right, yes, obviously, because here the degree of the variable, if you see, that is n, it is 2, that is non-negative, 1 non-negative, 0 non-negative integer. So this is a polynomial. Now if asked to find the degree, this is very easy. You have to just look at the highest power of x in that polynomial, but also you have to look at the coefficient as well. So since here the coefficient is not 0, so we can define the degree of a polynomial like this polynomial, and here it is 2, the degree is 2, and this is an is not equals to 0. We have checked both of the conditions, then only we have defined the degree of this polynomial, correct? So I hope that this degree thing is also clear. These are very basic topics, all of you must have read these topics, but like this condition you may not know, so I have told you this condition. Now remember this condition, okay? So this also gives us the reason why we have included this condition here, because if an is equals to 0, then this would not be, this will no longer be a polynomial of n degree, right? Because if this is 0, this whole term is going to be 0, and this will no longer be a polynomial of n degree. That's why we have written this condition here. So I hope that you have understood about polynomials and about the degree of polynomial. Two conditions are very important: highest power of x and the coefficient cannot be 0. Now let us move on to types of polynomial. Types of polynomial. Okay, another thing that I forgot to mention, that I have told that why this is called leading coefficient. I will tell you, because now what is a leading coefficient? Leading coefficient is the coefficient of the variable that has the highest power. Like here, this term has the degree of this polynomial, so the coefficient of this variable is known as the leading coefficient. That is, px is a polynomial, and xn, and the coefficient of xn is known as the leading coefficient. If you want to write a definition, I will write it for you. If p of x is a polynomial of degree n, then the coefficient of xn is called the leading coefficient. So I hope that you understand what is a leading coefficient. Very simple. These are just the terminologies of, so not very important, but you can remember this, correct? Now let me talk about where I was, that is types of polynomial. Now if I talk about the types of polynomial, the first one in our plate is monomial. Now what is monomial? Monomial is a polynomial with only one term. Mono means one, okay? So one term, only one term is called a monomial. Like for example, 3xy square or 3x square, like this. But again, if you write that 3 root x, this is not a monomial because this is not a polynomial. Why? Because the power of x here is not an integer, so this cannot be a polynomial. Okay, so there's small things you have to remember, that what are polynomials, what are the conditions for an expression to be called as a polynomial. Okay, so I hope that this you understand. Monomial, similarly binomial and trinomial. Binomial, I'm not giving too much emphasis on this types because these are very simple and all of you know this. Similarly, binomial means 2 and tri means 3. So again, two terms will be in the expression, or the polynomial will have only two terms. Similarly, in trinomial, the polynomial will have only three terms, correct? Remember, first of all, an expression to be called as a trinomial is that that expression has to be a polynomial. Then you have to check how many terms that polynomial has, then only you can say if it is a monomial, binomial or trinomial, correct? So I hope that you understand all of this. You know all of this, you can take examples, you know. But let us move on to the more important part, something that you may or may not have heard. Okay, so let us talk about monic polynomials. What is a monic polynomial? Again, very simple, a polynomial with leading coefficient 1. Like in the general form that we saw, so here px will be a monic polynomial if an is equals to 1. If this condition is true, then only p of x is a monic polynomial. Okay, so This is why it was important to define the leading coefficient. So now you know what is the leading coefficient, and now you also know that what is a monic polynomial. A monic polynomial is a polynomial with leading coefficient 1. Like in, so if I write generally, so this is the general form of a polynomial, and here the leading coefficient is an. So this general polynomial will be called a monic polynomial if and only if that the leading coefficient is 1. And if you now, this is a very common sense, if you want to write the general form of a monic polynomial, this will be obviously this one. Very logical, right? Because here an is 1, so we don't need to write. So this is the, you can say, a general form of a monic polynomial. Correct? So I hope that you understood what is a monic polynomial, and you also understood what is a monomial, binomial, trinomial, and monic polynomial. Now let us move on to more important polynomials, that is fifth, right? So fifth will be constant polynomial. Now if we talk about constant polynomial, what is a constant polynomial? So constant polynomial, as the name suggests, is a constant. Say a naught. This is a constant polynomial. Now how? Now you can check the what to say that you can check the conditions, right? So if a naught, now this is a constant, we are talking about constant polynomial. So for an instance, I am ignoring the fact that a naught can also be equals to 0. So this condition I am not taking right here, because that is another type of polynomial that we are going to discuss right after this type. Okay, so don't think that a naught is 0. Correct? So a naught can be any number except 0. So now check the conditions. So here, can we say that the power of x is 0 here, multiplied by x raised to the power 0? This is nothing but a naught only, right? So see, we defined as a naught cannot be equals to 0, and here also we find that a naught is not 0, and we define that n has to be a non-negative integer. Non-negative mean that we also include 0. So here also you can see that the power of x is 0. So both the conditions are satisfied, so we can say that px is a polynomial. And if asked that tell me the degree of a constant polynomial, what would be, what it would be? So it will be nothing but 0, right? Because see, the highest power of the variable in this whole polynomial is 0, and the leading coefficient, like the coefficient of that variable, is also not 0. So we can definitely define the degree of constant polynomial as 0. Correct? So I hope that you understood what is a constant polynomial. Constant polynomial is nothing but a constant number, and you can write the constant number in this form as well. From here we have got the degree of a constant polynomial. Now comes the most interesting, zero polynomial. Now what is zero polynomial? Zero polynomial is nothing but zero polynomial. Now see that if you ask me what is the degree of this polynomial, like what is the degree of zero polynomial, so it is undefined. Why it is undefined? Now you can say me, sir, why undefined? Because 0 multiplied by x raised to the power 0, here also it remains 0. So why can't we say that the degree of a zero polynomial is 0? Because while defining degree of a polynomial, we have talked about a condition that an cannot be 0. An cannot be 0, and if 0, we cannot define the degree of that polynomial. So here, as you see that, no doubt this is the highest power of x in this polynomial, but the second condition is not satisfied, that the coefficient of this cannot be 0, but here it is 0. So what we can say that the degree is undefined here. That is why I talked about that condition in the degree of polynomial. It is very important to define the degree of polynomial with these two conditions. Not only degree of a polynomial means that the highest power of that variable in the polynomial, but also that the coefficient cannot be equals to 0, and if 0 then the degree is undefined. Correct? So I hope that you have understood the zero polynomial and the constant polynomial. Now let us talk about a polynomial, another type of polynomial. Very simple. This is called the homogeneous polynomial. Homogeneous polynomial. Very simple. What is a homogeneous polynomial? A homogeneous polynomial is the polynomial where all the terms have same degree. If I want to define a homogeneous polynomial, it will be all terms having same degree. Example, if you ask me that 3x square plus 4xy plus y square, see all the terms have the same degree, that is 2. Correct? That is, now homogeneous polynomial you cannot define for a single variable. Like if you take example of 3x square plus 2x plus 1, so you cannot say that this is like you cannot define a homogeneous polynomial because there is only one variable. But it is useful when we take a polynomial of two variables or three variables. For example, 3x square plus 4xy plus 3z square plus 5y square plus 6yz. Correct? So see, all the variables have same degree, so this is a homogeneous polynomial. But for example, again, if we talk about this one, okay, I delete everything. Okay, I hope that you had noted all of this. Okay, so I was talking about this example, 4x square. Now can you tell me that is this a homogeneous polynomial? Is this a homogeneous polynomial? No. Why? Because see, here are three variables x, y and z. Now we see that the degree of x is 2, that the highest power, first of all, the highest power of this polynomial is 2. That is that we can define that the degree of this polynomial is 2. Also check the coefficient, right? So since the highest degree or the degree is 2, now look at for x has 2 power, so okay, then z has also 2 as a power. So but another term is missing, that is y here has 0 power, but here that y has the highest power of 1, while x and z has the highest power 2, that is equals to the degree of the polynomial. So this is not a homogeneous polynomial because the y highest power is 1, that is not the degree of the polynomial. Okay, I hope that you understand this part. Correct? Again I am explaining, because here x is the power of x is equals to the degree of the polynomial, the power of z is also equals to the degree of the polynomial, but when we look at y, the highest power of y here is 1, that is not equals to the degree of the polynomial, so hence it is not a homogeneous polynomial. Correct? Now I think with that being said, we have defined all types of polynomial that we could. Now let us move on to the next topic, that is value of a polynomial. Okay, value of a polynomial, say p of x again is the polynomial. So how to get value of a polynomial? This is pretty simple. Say this polynomial is defined as 3x squared plus 2x plus 5. Okay, like this. So how to get to any value of a polynomial? Just you have to replace the x with any number of your wish. For example, I want to find the value of this polynomial for x at 1. So p of 1, we have to replace x with 1. Okay, see this, p of x means that this polynomial is in the variable x. Okay, so if we replace x by 1, so this now becomes p of 1. So this means that in place of x, like wherever in the polynomial there was x, we have to replace that x with 1. Okay, so if you do that, what are you going to get? So 3 multiplied by 1 square plus 2 multiplied by 1 plus 5, correct? This comes out to be 10. Okay, so again, now if another person wants to find the value of this polynomial at x equals to 2, then he can do so by replacing x in this polynomial with 2, and the answer that he will get is the value of this polynomial for x at 2, correct? Now this is how if we define the value of a polynomial. And in general, if you want to define, you can say that you can find the value of this polynomial or any, since we are talking about general, so let's take the general form, that is an a naught. So if you want to find the value of this polynomial for x at a, or say alpha, x at alpha, so you have to just replace here x with alpha. So you will write p of alpha here and replace all the x with alpha, and you will get your answer. And the answer that you will get is the value of this polynomial at x equals to alpha. So very simple. I also have showed this with an example, so I prefer you to understand this concept with this example. Okay, so I hope that you now know what is the value of a polynomial. Now there is a special value of a polynomial, special case. In this value of a polynomial, this is also known as, also called zero of a polynomial. Okay, zero of a polynomial. Now what is this? Again, p of x is a polynomial. Let me define it as plus 2. Okay, so now what is the zero of this polynomial, or what is zero of a polynomial? Now say for example, I am, now you know roots obviously, right? Because in the basic math also I have discussed roots. So since it's a quadratic equation, this will have 2 roots, right? This is also a theorem kind of essay. I will discuss this after this portion. So this will have 2 roots. So if the roots say are alpha and beta, correct? So if you replace x here with alpha, or in other words, you are just finding the value of this polynomial at x equals to alpha, then what you will get is this polynomial's value will be 0, correct? Here alpha is -1 root of this quadratic is -1. So if you want to find the value of this polynomial at x is equals to -1, then you have to replace x in x with -1 in this polynomial, and the answer that you will get is 0. So we can say that -1 is the 0 of this polynomial. Or if you want to write the definition, you can write it as known as 0 of a polynomial. Correct? So this is it. So the value of a polynomial at for which p of x is equals to 0 is known as the 0 of a polynomial. So I hope that you have understood what is a 0 of a polynomial and what is the value of a polynomial. 0 of a polynomial is just a special case of value of a polynomial, where if you replace x with a certain number and you get the value of that polynomial as 0, then that value is known as the 0 for that polynomial. Correct? And now another thing that I want to talk about is I just said it in the last page. This is known as fundamental theorem of algebra. Fundamental theorem of algebra. Okay, what is this? This theorem says that the number of roots of a or the number of zeros of a polynomial is equals to the degree of the polynomial. For example, if p of x is a polynomial with degree n, okay, with degree n, then the number of zeros of this polynomial is n. Or in other words, if I take an example, say this quadratic, okay, so this is also a polynomial, okay, and the degree of this polynomial, if I say it as p of x, and the degree of this polynomial is 2, because see the coefficient is 1, so we can define the degree of this polynomial. So the degree is 2, hence the number of zeros of this polynomial is also 2. Correct? And here it will be plus minus 1, that is one root is 1, another root is minus 1. Correct? Sorry, minus 1. Wait, minus 1 is the root. You can find it with Sridhar's formula, right, that I discussed in the basic math. So the main thing is that, let me write it. Say p of x is equals to degree of p of x. Correct? Very basic thing, very logical thing, but again this is a theorem. I hope that you have understood, right? For example, if you take a cubic polynomial, that is a polynomial with degree 3, for example x cube, let me take general, ax cube plus bx square plus cx plus d is a cubic polynomial. So can you tell me how many, this is an equation, can you tell me how many zeros will this polynomial have? So you will say that according to fundamental theorem of algebra, this polynomial will have 3 roots, 3 zeros. Correct? Because the degree of this polynomial here is 3, hence the number of zeros will also be equal to the degree of the polynomial. So I hope that you have understood also this theorem. Now let me move on to factor theorem and remainder theorem. Again, this is connected, they both are connected. If I talk about factor theorem, Now what factor theorem says? Factor theorem says that if x minus alpha is a factor of a polynomial, say p of x, then p of alpha is equals to 0. Okay, so this is what factor theorem says. Now I'm not going to prove it because you have seen the proof in class 9th, or even nowadays it is in class 8 as well. So I'm not going to show you the proof. This is what factor theorem says, very basic thing. For example, say can you tell me if I have a polynomial x square minus 2x plus 1. Okay, now can you, and I have said that I have asked you to see if x minus 1 is a factor of this. Now how will you check that? See the statement x minus alpha. If x minus alpha is a factor of a polynomial f of x, then f p of alpha is equals to 0. For us here alpha is 1, so replace alpha here. This is p of x, so replace it with alpha. This will be 1 square minus 2 plus 1. Again this is 0, so we can say that x minus 1 is a factor of this polynomial. Okay, just replace alpha in the original polynomial, and if the outcome is 0, then it is a factor. Now you may have a question that, sir, if p of alpha is not equals to 0, then we will definitely say it is not a factor. But can we say that the thing that we will get after putting the value of x as alpha is the remainder when x minus alpha divides p of x? Yes, you can say that. What I said, this is remainder. This was a factor theorem, and the one that I have just told you is remainder theorem. That is, in the factor theorem you have checked if x minus alpha is a factor of this one. Now what if you want to check the remainder, like you don't know if x minus alpha divides p of x, right? So how to find the remainder? You have to just do the same, like replace x with alpha. But if this time p of alpha is not equals to 0, say p of alpha comes to be some k, then k is known as the remainder. That is, when x minus alpha divides p of x, k is the remainder. What I've said is, if x minus alpha does not divide p of x, then remainder x minus alpha divides p of x is p of alpha. For example, x square minus 3x plus 1, if asked to find the remainder when this polynomial is divided by x minus 1. So what will you do here? Alpha is again 1, so you have to replace p x as 1. So from here you will get 1 square minus 3 plus 1, so you get the remainder as minus 1. So minus 1 is your remainder when x minus 1 is x square minus 3x plus 1 is divided by x minus 1. Very simple. You have been studying this for a long time. I am just brushing up the basics. Correct? Now I hope that this factor theorem and remainder theorem is clear to all of you. Here k is the remainder. Again, if you want to look at the proofs, you can check in the NCRT, you will get it. Proof is not main, right? Very basic things. Now comes something advanced, that is known as the rational root theorem. Now what this theorem says, again, say rational root theorem is, say we have an equation. Now what is an equation? First of all, again, a polynomial bounded with some equality, like p of, if I say p of x is equals to 0, or any constant, then we bound this polynomial, right? And then we get a specific value of that polynomial, that is the zeros of the polynomial. Like, see, I know you know what is an equation. Again, see, if p of x is a polynomial, and if we bound this polynomial with an equality sign, then this becomes an equation. To be very simple, this is what an equation means: bounding a polynomial by an equality sign. Okay, so I hope that you know what is an equation now. And we talked about roots as well. What are roots? Roots are basically values for which the value of an equation comes to be 0, correct? So if an equation say, I'm taking a general equation, a n x raised to the power n plus a n minus 1 x raised to the power n minus 1 plus a naught. And again, this is also the general form of a polynomial, but to be an equation we have to bound it with an equality, so I put here equals 0. Okay, so this, if this equation has rational roots, in the form p upon x, again, now you have to apply the conditions of rational numbers, that is p and x are relatively prime, that are co-prime to each other. I hope you know what is co-prime, that is they have no common divisor except 1. Okay, and p and q belongs to integer. Then this theorem says that p divides a naught and q divides a n. Have a look at the statement and try to understand. If a equation, general equation I have written, has rational roots in the form p upon q, where p and q are co-prime to each other and p and q are integers, then p divides a naught and q divides a n. This is very useful. Even one question came in IMO based on this simple concept. Okay, International Mathematics Olympiad, I don't exactly remember the year, but a question came based on this theorem, very simple theorem. Okay, I hope that you understand now. How the application of this all theorem we will discuss in the next lecture. This is again the basic, I am just building up basics, then we will move on to the advanced in the next lecture. So I hope that you understand this theorem, note it down. Now another theorem is that integer root theorem, that is basically the same, or you can say integer root theorem. Now how is the same? Now can you tell me that this p upon x, when will this be an integer? When q is 1. So if q is 1, then can you tell me the how will the theorem be now constructed? if P upon Q, this I say that, okay, let me write the definition, then I will explain. If an equation, again you can write all of this here, has integer roots, then integer roots in the form P, right? Because Q here will be 1. See, P and Q are integers, so if Q is 1, then P is an integer, right? So if P is an integer, now you tell me what will P divide. P will again obviously divide A naught. P will divide A naught, and since Q is 1, so we cannot say now that Q will only divide AN, because 1 can divide any number. So this is the same as rational root theorem, but in this case just the Q is equals to 1. That's why we have changed all of this. Correct? Very important, these two theorems, understand this. If any problem, you can comment down below. I will try to help you out, or you can join our Google Classroom where you can get in touch with us personally, right? So I hope that you understand. Again, I am making understand once again. So what is rational root theorem? Rational root theorem is a theorem which states that if an equation has rational roots, and I hope that you know what are rational numbers. Rational numbers are always in the form P upon Q, where P and Q are co-prime and P and Q are integers. Then P will divide A naught and Q will divide AN. Correct? This is the theorem that P will divide A naught and Q will divide AN. Now from this theorem only another theorem comes, that is integer root theorem. That is, if the equation has integer roots, then the roots will divide A naught, that is the constant of that equation. It will divide the constant of that equation. Very simple. Why? Because Q for the integer root theorem is 1, so the only possible way to define is P. So only P, we can only state the theorem for P, since Q has become 1, so it can divide any number, so only we can specify here P. So P will divide A naught. Correct? This was your rational root theorem and integer root theorem. Some amazing questions you can solve it, some amazing questions you can solve on the basis of these theorems. We will discuss it. Give me some time, I will bring extremely interesting questions. Okay, now your basics of polynomial is done. Now I will give you some identities that you need to remember. Again, these are very simple identities. You have been looking at this is just to brush up. Remember these identities, this will be very useful. So the first, to start with, the basic is x square minus y square is equals to x minus y multiplied by x plus y. Simple. All of you understand this? Okay. Now second one is x cube plus y cube. If you want to, now there are two forms. One form is the factorized form and another is the general form. So if you want to write this expression in a factorized form, okay, so the factorized form is x plus y multiplied by x square minus xy plus y square. This is the factorized form. And then the normal form is very simple, that is x plus y whole cube minus 3xy x plus y. Okay, now one interesting thing that I want to remember there. Now can you tell me if this, okay, I erased everything. Wait, let me write it again. So the first one, x square minus y square, that is equals to x minus y, and the second is x cube plus y cube is equals to x plus y multiplied by x square minus xy. This is also equals to x plus y. Okay, now my question was, can you tell me if this expression or this, first of all tell me, is this a polynomial? That x cube plus y cube, can we say it is a polynomial? We can say this is a polynomial. Now can you tell me if this is a homogeneous polynomial or not? Yes, this is a homogeneous polynomial because all the terms have the same degree. That's why we can here also, this is also a homogeneous polynomial. So I hope that up to this much is clear. Now let's move on to the third one. Third one is x cube minus y cube. Again the factorized form, or this can also be written as correct. Remember this, these are very useful, very simple to remember. Now next one, okay, this up to the three identities were okay, but from the fourth the identities are very important, very important. This identity, you have seen these identities before as well. This one, very important identity. Okay, this is the identity, x cube plus y cube plus z cube, x cube plus y cube plus z cube minus 3xyz is equals to x plus y plus z multiplied by x square plus y square plus z square minus xy minus yz minus xz. Okay, another special case can be made within, this is not a special case, this is very logical thing. If very logical, if this one is 0, if this one becomes 0, this whole term will be 0, so it comes out to be x cube plus y cube plus z cube minus 3xyz is equals to 0. This comes out to be x cube plus y cube plus z cube is equals to 3xyz. You can say it a special case. This is always true. It's better to remember this way rather than remembering the special case. If x plus y plus z is equals to 0, then this is natural to come. This result is very natural if this becomes 0. So I prefer you to understand this and remember this one. This one will come automatically. Okay, and the last one is extremely important. Extremely important, you have to remember this, very important. This one is x square plus y square plus z square minus xy minus yz minus xz is equals to, let me write it, this one is equals to half of x minus y whole square plus y minus z whole square plus x z minus x whole square. Okay, this result is very important. I'm emphasizing this again and again. This one is very important. You have to remember this result. You can also do the factorization very simple, extremely simple. You can do it on your own. So this result you must remember. So these were some identities that are necessary for PRMO, and this part may be useful for PRMO, may not be useful for PRMO, that I don't know, but this is very interesting. If you love maths, then you will find it interesting and you will learn this. So yes, this was it. So I hope this lecture was useful, and I hope that you were able to understand at least something. Degree of a polynomial, always remember this condition, correct? And finally, please fill up the form. If you want to ask any question to Dr. Amitabh Tripathi, you can ask him. This is a great opportunity for all of the Olympiad aspirants. He was the ex regional coordinator of RMO, so you can ask your questions to him. What you have to do is fill up the form, and the link has been given in the description, so you can go and check out the link and fill up the form to ask your question, and he will answer. If you ask a good question, we will select that question, and we are going to end we are going to stop collecting the responses of the form from uh, Friday is the last date for you to fill up the form, so fill out the form quickly. Thanks for watching this lecture. I hope you were able to understand.